All right. I'm going to really try to pay attention to this message thing, but I'm not. Sometimes I just forget. But anyway, if you want to, those who are online, there might be somebody online, or it could be somebody here online. And mute yourself if you are online. Mute yourself. Mute yourself. I think I can mute you. Mute. All right. Okay. All right. So this class is ICS321, and this is welcome. My name is Dr. Richard Halverson. You may have watched my video. I made a little video. This class I did that, right? I made a little video of the introduction. I've taught this class the most often of all the classes I'm teaching this semester, so I'm going to rely a lot on what I've done previously. But the advantage of that is I got the stuff I have the content down pretty well and can present it to you efficiently, and so you are able to benefit from that, not spending a lot of time spinning your wheels or anything. So the class is here. If you ever cannot attend the class, you're welcome to call in, and you're also if you can't do either, you can always come back and watch the video. And the videos will always be under here. Video class videos. In fact, I'll tell you what. I'm going to open me up my other La Lima, so it looks like what you guys see. Remember this password. So this is what you guys see. So the videos over on the left here, there's resources, and the videos are always going to be here under videos. And this is the introduction to the class. And so, this is actually a YouTube one. But from then on, there'll be freeconferencecall.com, and freeconferencecall.com videos are actually better than YouTube because you get two videos. You actually get a video from the camera, and you get a video from what's captured on my screen, anything that's on my screen. And for this class, of course, the most important thing is going to be my screen, so you can actually just make the little video of me real small. But sometimes I might, probably not, there's no chalkboard here, but other classes I might have a whiteboard or something, in which case you would want to look at me. But anyway, so in this class you may wonder, why do you have the camera? And a lot of it is sometimes I might be really being facetious and don't want you to take me seriously, but also I need the habit. It's the habit of turning everything on and then turning the record on and then recording the class. And in the beginning, I'll tell you, I messed up a lot, and it was unfortunate because folks were depending on being able to see something again. Oftentimes, I will start an assignment, or I'll do an assignment for the most part, or like there's going to be like quizzes every day, and I'll start you out on the quizzes. And so so you may want to, and sometimes the quizzes might be so hard that you don't want to just finish them during the class. The intention is that you know everything by the time you take the quiz. You've already been prepared for the quiz, whether that's watching the video the night before for today's class or by coming to class. But if you cannot, watch in real time and you have to watch it later, or it's so difficult that you want to take some more time to do the quiz, then it's good to be able to rewatch the video. So anyway, that's there. This is the textbook. It's called Relational Theory for Computer Professionals, and you can get it on Amazon. And today it's $35.81. It was cheaper when I made the video. Until you can, let's see, there's another, this link to it. I'm going to need to refer to the textbook in class. So there's a version here. If you can get by with this, then that's great. I actually sprung for the the video. There's a video set that comes along with this textbook. He actually used this textbook as a reference for a seminar for teaching computer programmers about SQL and relational algebra from the perspective of you already knowing how to program, you already knowing programming languages. You've already experienced a couple of programming languages at least, and you understand about assignment statements and expressions and variables and constants and classes and all that. But you don't know anything about SQL. You've heard of it, but that's it. Maybe you've never written an SQL statement, or maybe you've never experienced executing an SQL statement. But this textbook is designed for you, if that's you, because he basically teaches all the principles. He starts by teaching all the principles from a programming language paradigm, and we get pretty far. We're going to get all the way into October, and I'm not going to give you an assignment. You'll take quizzes, but the first assignment, which is where we actually start doing stuff in SQL, is going to come in October, and you will have had a few chapters. And then when you start learning SQL, we can talk about how faithfully SQL implements the concepts of relational algebra that we've learned. We'll learn it's not very faithful, but it's from that kind of perspective that it's useful to compare different SQLs. I mean, there are different SQLs, of course, different versions of SQL. One main thing is that SQL is record of a table centric. I mean, we think about the records of a table, whereas relational algebra, you think of the table as the variable, and you have a variable, and the type of the variable is defined by what the columns are, what the fields are of that table. If you think of a table that's got columns, and the columns are, you can think of those as attributes. So it's a different perspective, it's real useful, and I think it's kind of a fun way for computer scientists to learn this stuff. But it's nice because there's these nice videos that go along with every chapter. And
hi, and welcome everybody. Welcome to the seminar. This is relational theory. It's relational database theory, for computer professionals. And this is me, Chris Davis.
And so he's got a very pleasant, style of lecturing, and the students around are not too bright. I mean, they ask simple questions that you will probably know the answer to, and you ask them. So it keeps it real simple. But anyway, that's a useful way to learn this stuff. And to be honest with you, I think if you just watch the videos and you never open the book, you probably learn everything. And if you don't if you don't have the patience to watch the video and you just want to take the quiz, you like working backwards. So you take the quiz, read the question, go to the book and find where the answer to the question is, and some people work better that way, and you never. That usually works too. And maybe even if you only come to class and you pay attention every day religiously, I know there's going to be some people I see every day, and there might be others that I'd see today, and maybe I'll see again sometimes. But that might be okay too. That actually might even work too. But you're not going to do one way all through the whole semester probably. You want to rely on these different modalities for learning the material, and so you kind of have an opportunity to do that. So anyway, so that's the videos. And then now there is this other thing in here that I've thrown in here to sort of, and I don't really say this, but assignments are sort of come later. But but if you feel nervous about not doing a lot of work for this class for a while, you know, I've actually had people who have contacted me, you know, after about a month, hey, you haven't given us any assignments, or am I missing something? But I have this real convenient way. The trouble is the textbook doesn't cover everything that we need to cover in this class. And some things it doesn't cover, it covers kind of weakly, kind of in a weak manner. And so what I did was this is a favorite, kind of a favorite of you know, quick study. I started using this when I was teaching a business class at West Oahu, and it's a real way of learning by giving you short little modules that, you know, 8 minutes per module, and a lot of them are watching a little 5-minute video, and then at the end you take this 5-minute quiz, and it's all, you know, take as many times as you want and all that, and you just, you know, you learn little things important. So you just go from here, you click continue, and you sign up, and I actually already have an account, so how would I mean, I have a student account that I've set up already, but how do I log into my account? I wonder. Go here, and I go here, and I wonder if maybe I've never logged into this computer. Let me try. Forget it. I don't want to do it too many times because I don't want to get my computer locked out. But well, let me try. I do all my work on a different computer, and this is the computer I cart around with me. It's more. So anyway, I will solve this problem later, but it doesn't. It's not for a while. But actually, you can actually look at the courses here. You don't have to sign in. Okay, so let's look at. Let me just really quick see if I can do this. Educational level subjects, all subjects. All courses, science courses, all courses. Computer science. Computer science, and you go to the database ones. And like the first one is, let's go to the end here. I'm wasting time here. I'm sorry. Computer Science 303 is what I'm looking for. But anyway, we can. I'll solve this problem, but you can just do it. Create a new account, and you can see. You can take a look at that. All right. So anyway, that's that. And okay. Now the actual calendar looks like this. So there's a daily quiz, and you'll notice I posted up the first quiz, and I'll get to that in a moment. So this is what the calendar looks like, and it's just all the chapters. And I do some a little bit out of order because I want them to sort of line up with the study.com stuff. There's the first study.com module has to do with storage technologies, things like the difference between magnetic hard drives and solid-state hard drives, and RAM and ROM and non-volatile memory, and then more advanced storage like optical disks and holographic disks and cloud storage and all that. So there's a whole module on that, and there's about 15 or so modules, and then short little things. And then the second one has to do with the database design process, and you should be able to recognize an entity and recognize and read an entity relationship diagram, and probably even make one. And it just shows the relation. That's how you express the relationship between tables in a database, and then the various design process and the schemas and so on of defining a database. And then the third module is advanced SQL queries. There's a bunch of different kinds of joins and all that kind of stuff, and grouping, aggregate functions, and so on. And the study.com modules are really kind of simple, and you sort of give you these simple examples, and then you take the little quiz. And, but they do kind of correspond with some of these. So that's why transactions comes after. Chapter 8 is going to come after some of these other ones. And then at the end, we're going to have a project. Starting about the middle of November, there'll be a project, and we'll talk about. We'll choose a technology to implement, and it'll be a database project, but preferably a web-based database project. And you'll make it. You can get into groups and so on, and make something. At the end here, so we're going to learn how to write stored procedures and triggers and so on, and how to create transactions, indivisible sets of SQL commands to make database updates and so on. The thing about a database is that it's the database is responsible for making sure that the data in the database is always correct according to the set of constraints that you've defined for it. And there can be simple constraints like every field that's got the guy's hourly rate has got to be decimal number. It can't be you can't accidentally put a word in there, or it enforces data types being stored like nothing else, as carefully, or even more carefully than defining the type in a program, because when you define a string, you have to say the maximum number of characters, and you don't have to do that all the time in programming languages. But not only that, you can define relationships between tables. Like in our database, we'll have a table of suppliers, and we'll have a table of shipments where suppliers have shipments in progress. And if we go in there and we try to delete a supplier because we're not doing business with that supplier anymore, however, there's still a record in the shipments that is associated with the supplier, because this supplier's got something that's still shipping. The database won't let you do it, and you just set it up that way. And if you got a record in here that points to a supplier, the supplier's got to be in here. We're not going to let you change anything that would violate that rule. And so, but you can even do business constraints, like no employee can make more than their boss. Whatever. That company's got that rule. That's the rule. You put it down in the database management system, and that's enforced. It doesn't do something alternatively. It doesn't do it. It rejects the the command. And then, of course, you have things to handle that. All right, so as far as my grading goes, there's going to be these daily topic quizzes from the videos in the textbook, and they're submitted on Laulima. You see them on Laulima. They're submitted on Laulima, and they're daily quizzes. However, they will be accepted for full credit up to 1 week after. I understand, stuff comes up, so and I don't want to deal with people coming and say I couldn't do it that day. That's fine. You manage. I'm not that strict about stuff. So just after that, then you might get some points deducted because it's up to the convenience of the grader, or it's up to the grader's schedule, actually. The time I spend, preparing and doing a good job here in the classroom is pretty high up on my list of priorities. But for graduate students who are have the job of supporting us, we're kind of low because they got much more important stuff to do because they're doing their research and they want to graduate, and they've got deadlines too and everything. So we want to be accommodating for that. Okay, and then so that's 30%. Then there's assignments. So there's like 5 assignments, a couple of ones at the beginning that are kind of manini, and then just to get you going. And then there's a 10-point assignment. And there's 2 15-point assignments. And by the way, these points are like percentage points, towards your grade. I mean, 100. You get 100 of them, and that's an A, the highest A. And then you get, but if you only get 78 of them, then that's someplace down here. Okay, so when we say a 5-point assignment, okay, these 5-point assignments are things like just pay attention and do it, and then you'll get all 5 points. Okay, well that's like getting a perfect score on 5 quizzes. Okay, so it's kind of not balanced that way, but that's how it is. But it's an important but the assignments are important because they sort of build on each other, and the assignments is like where you do stuff, and it's you learn the skills that you're going to use if you go off later on and have to write SQL. And then these study.com quizzes are kind of simple. It's just a half a point per quiz, and there too you can take them as many times as you want. So they're pretty easy. In fact, you might just want to first go in and try to do the quiz first just to see. I mean, if you happen to know the topic. A lot of the stuff in the first set in the first set are ICS321 stuff, which and you guys know all that stuff pretty well, so you might just be able to buzz through those things. But it's important that it's for this class that's important that you learn about data storage technology. It's just the technology itself and where it's headed. So daily topic quizzes submitted 1 week after will be subject. After that, it's subject to a point reduction. 1 extra credit point will be awarded if your assignment is handed in by the due date. Okay, so this is kind of a strange way of doing it, but just to encourage, the assignments are the hardest for us to grade, take the longest because we contemplate and want to make sure. Oftentimes with assignments, you're grading the assignment. I'm talking about the later ones down here. You're grading the assignments, and after you grade about 5 of them, you say, wow, that deserves more weight than I've been giving it. These last 3 people did a really good job on it. I didn't realize you could spend time on it. So you want to go back and you want to make adjustments and stuff. So that's why we'd like a lot more. That's why we'd like more time. And so to encourage you to hand it in on time, we actually give you an extra credit point. Okay, so now there's 5 assignments, and so now we're up to 105 points possible down here. So 105 is more than. And assignments over 2 weeks late may be subject to a point reduction. No credit will be given for daily quizzes or assignments submitted after Monday, December 10th. And that that's the day that, the last day of class is Monday. This is a Monday, Wednesday. So the last day of class is like December 7th. Wednesday, December 7th. And then there's a couple of study days. And then Monday, December 10th would be the final, but we're not going to have a final. But so that's the day I'd like you to have all of your daily, all your late daily quizzes or assignments by that day. Okay, daily quizzes and assignments. Those are the ones that that give us the most trouble when we have to go back and grade them after everyone else is, after a bunch of people have handed it in and we're done, and then they come in. I don't want to discourage. I want you to always feel it's worth it to hand in an assignment or do a quiz, even though it's way late. Stuff happens, except for after December 10th, it becomes too much of a burden for us. Except for assignment 5, because you're going to be working on that till the end. And then the study.com quizzes, of course, I just go in and grab the grades and throw them in La Lima, and I don't need to do anything, so you can, so those can come at way at the end just before I have to submit grades. I'll just pop those in and see if it affects anybody's grade. Well, it'll be 20 percentage points, so yeah. But all right, so now on the okay, so we have resources and the class videos. I told you about this already. Quizzes are here. Relational date. The textbook is here. And then this is the video series. Oh, the slides for the textbook are here. Assignments. I'm gonna. The quizzes are here. There's gonna be 30 quizzes here. And the reason I put them in the assignments tab is so that way you can submit them here. It's all set up to do that, and it's all connected to the gradebook. But so they're called quizzes, but they're almost like daily assignments. You can kind of think of them like that. But then the regular assignments that I've talked about, the 5 SQL assignments, I kind of have those up here just so I know just so I keep track myself, and you kind of know what's coming. So the first quiz is this. Okay, so I'm gonna go through the slides. I guess it's 2 o'clock. This class goes till 2:45. Okay. So I guess I'll just explain the quiz real quick here, because a lot of you have, some of you may have watched the videos and ready to hand in the quiz or whatever. So you've learned, if you've looked at Chapter 1, that this is the little database that we're going to be using, and we're going to be using this throughout the whole semester. And it's a nice database because it's got enough of the little components in there, enough weird things and everything that we need to be able to learn almost all the concepts. And so the S is the suppliers database. The context is that you have suppliers shipping parts. And the parts are in a warehouse, and the suppliers are headquartered. The suppliers are headquartered in various cities. You see here, suppliers, and the parts are warehoused, I guess, or inventoried in a particular city. I guess you can think of it that way. And at any point in time, there's shipments going on, and I guess, and this table keeps track of those. So you'll notice some things about this database. These tables here is like this. Some of these are there's a header. Each table's got like this header, and there's columns, and the columns are named, and names are up in the header here. You notice that some some column names have a double line underneath. Okay, that indicates it's a special column, and it's a primary key column. A primary key, it has the property that it's unique primary key for each record. You can think of these as records. So there will only be one S1, there will only be one S2, and so on. Same with the part numbers, unique part numbers. And in fact, because of the primary key, then you can talk about the whole part by just saying P3. You go, what's P3? Oh, it's a screw. What color is P3? Oh, it's blue. And same with suppliers. You can just refer. Now this table here, though, is different. This requires two columns together to uniquely identify a row. And so we have S1 here is actually in here 6 times, but you'll notice each time the part number is different. Okay? And there's a quantity field here. So it's like S1P1 would be Smith from London shipping red nuts, also from London, and 300 of them, for example. Anyway. Okay, so the first question, so that's just an explanation of the table, of the database. The first question is not really related to the table, I guess. It's the first chapter talks about categorizes the kinds of controls that a database is supposed to control. And there's 4 of them, and then here's some questions about something about a type of control, about what a control does. Is what type of control would not allow you to delete a supplier that has a shipment in transit? Okay, that's a particular category of control, and so you answer that. And by the way, if you go to the textbook, you notice there's examples, and if you just read, oh, that's like this one. And then the first chapter also introduces it starts to talk about the different, sort of a review of programming languages and what the different types of or statement types of programming languages are, and types and variables and statements and that sort of thing, expressions and assignments, and that's kind of what I'm getting at here with the second question. Is first of all, and the first chapter doesn't really explain. Okay, these are what are called tutorial D expressions. If you read the chapter, tutorial D I think it stands for tutorial database language. It's like a language that he's sort of created to sort of teach us this stuff. Every database class at this level has got a new language you have to learn. It's sort of just to teach the concepts, and this is the one for this textbook. So these two things produce the same table result, but there's a difference between the two, and you're supposed to say it. So anyway, and then so to answer this, you can open up this thing and type in your answers below it if you want. That would probably work for this quiz. You have to write the table, so you can actually make a table if you're handy enough with Word. You can just throw a table in there or whatever. But some quizzes, yeah. So there's going to be a quiz where you have to do a table. There's probably going to be a quiz or two where you have to finish an entity relationship diagram, and that'll be drawing lines between some module boxes. And if it gets to be like that, then you can so when you're done with your quiz, you submit it here. Now, if the easiest thing for you to do is to print the quiz, answer the questions nicely with your pen in hand, and then take a picture of the quiz with your iPhone, and then submit that, that's fine. Make sure it's a high resolution enough so we can blow it up, and so also when you're taking the picture, you're taking the picture. It's nice if you have an app like these scanner apps, because then they're good at sort of making sure you don't have to pay attention to the corners of the screen when you're taking a picture, so it sort of squares off the picture. I've had students send me stuff where they take a picture and there's like this thing and there's like some lighter paraphernalia in the back, and I'm going, geez, don't even see that. So that's what's nice about those apps. It doesn't do much better than you can do, but at least it's sort of I used to do photography for a hobby, so I pay attention to the corners of the screen when I'm taking a picture, but some people, when they're new at it, they don't. Okay, so that's today's quiz, and so you do it and submit it, and there'll be the grade book here, and you will see them as their answer. They'll see the quizzes accumulate here, so now just so you get an idea of what the first couple assignments are, you can look at these and see what they say. And these are kind of a reminder to myself, which is what I think is important. And this is going to be in like October. What is this? When do I? So I will give you this assignment. The assignment will be completely finished and polished, and all the hints in there that you need and everything to do it. You're going to have servers. There's a machine on the third floor, and you're going to have accounts on this machine, and you're going to have, so when you do these assignments, I'm going to be able to look and look right at them. So you just do them on your machine, and then I can go in and look and see that the tables that you are created correctly and so on. And it's also good because if you need some help. And you'll see, you'll see the screen that I use, or the thing that I use to look at your stuff, so you can look at it and see what I'm going to look at when I grade it, so you can make sure that it's in there right. But so you're not going to get this till October 1st, and we're into chapter 10 talking about SQL tables in this thing, and we've already talked about. Okay, so just to let you know a secret, a relation is the same as a table, except for a relation is the terminology that we use in relational algebra, and table is the terminology we use when we're talking about SQL. But they're the same thing, and it looks like a table. It's got a header, it's got a name, names of the headers, and it's got fields and all filled in and so on. And a rel var is a table that we think of as a variable, and if you think of an assignment statement, an assignment statement's got an expression on the right, and it's got a variable, a single variable on the left, and you evaluate the expression, and the result can fit in the variable, and that's what we do when we're doing an assignment statement. And expressions have variables in them, and there's operators that work on the variables, and multiplication, division, so on. And so that's how an assignment statement works. Well, a rel var is a table that can be a table like a variable. So the table has a particular structure to begin with that doesn't really change. That's like a strongly typed variable in a programming language like Java. You define what the type of the variable is, and then that's what's got to go in there. Same with a table. You define the rows and the columns, and that's what's got to go in there. And then you do operations on tables. Table and table do some operation on them, like a join or a select or something. And the result is a table, and that fits stuck right into this variable on the left. And when we're talking about tables, we call them rel vars, relational variables, I guess. And then so here we talk about keys, and I've already introduced you to keys and foreign keys. Foreign keys are I can just really quickly. So if we go to resources and go to the quizzes, and we look at the quiz, I talked about these two things as being the keys. This and these two together make up the primary key for this table. But this particular column here is a foreign key into this table. And this P&O is a foreign key into this table. So that's what foreign keys are. Where was I? I was, I can't remember where I was. Anyway, so this particular assignment is I'm gonna give you one big huge table that's got a bunch of stuff in it. It's got a bunch of columns and rows, and that table is actually not in an efficient form regarding normal forms. You want your table, you want a table, if a table is not in the highest normal form, that means it can be broken down into smaller tables that are of the highest normal form. And so that's the exercise. And it turns out if it's on a database, if you got the big table and you want to break it down, it's easy. You just do select insert. And so we'll do it in class, and then you'll do it. You know, a lot of you can do it right in front of me and when you're done, maybe, probably. And for this assignment, it's so easy. Anyway, so that's that experiment, or that's that exercise, and I haven't assignment, but I haven't come up with the table yet. But it's not going to be that big of a deal. And relational operations is going to create views or whatever. So anyway, all this terminology will become clear and apparent when we get there. So let me quickly figure out. So I don't need this anymore. I'll leave that up there. I don't need this. I got to figure out my password. So I'm going to download my did I cover everything in the syllabus? Just really quick, make sure.
All the way at the bottom for the grades.
Yeah.
So they overlap. So like, if I get an 87, do I get a B plus or a B?
Do you get the highest?
Awesome.
Yeah, I'm just stay out of the C range. You know, in my class, it's not whether or not you're going to pass, it's whether or not you're going to get an A. Okay, and if you don't get an A, you're just like, you know, you're lazy. I hate to say it. Now I give you a lot of stuff, but it's just a matter of doing it, and it's your doing it that makes you learn. Now, you know, there is going to be stuff at the end where you're going to have to use your imagination. You have to take some concepts and put them together in nice ways and everything. You'll be graded on that stuff, but that's at the end, and that's like, you know, you're around here someplace. But then, you know, you can make up by being diligent, or you can make up by handing stuff in right on time every time. And I've had there's just you have to have one of those things. You know, either be really good at doing something ass-kicking at the end, putting the concepts together in ways that we haven't thought of, and there'll be lots of ways that you can do that, or you know, you do real diligent, good, on-time work, complete assignments and stuff, but when it comes to the final project, it's like, yeah, everything works great, but you know, yeah, anybody could have done that. That's fine, but because there's a place for everybody, as long as you have one of those things. But lots of times when you're young, you guys are young, and I was young once, you're not developed in any of them completely yet. And there's a side that's better but you're not done developing, so you end up not getting as good grades as you should, and not finishing stuff, and if you only had more time, and all that. I don't want to sting you for not having enough time, and there's still enough time in the rest of the semester, but you do get stung if it goes past the semester and you don't get stuff done. Then you sort of lose your chance and that kind of stuff. Okay, so I'm gonna grab down the slides just so we can get an introduction to what like the content of the course. And so if you go to here, and you go to here, slides, and open this, open. So we don't assume, actually I guess I wonder if I can do this mode. What's up there? Okay, so I see this. I see the two screens. You see that screen. The folks at home see my two screens. That's okay. And let me, well, okay, so I'm not going to, I assume you know something about computers and programming, but not anything about databases. And the objectives is to explain a relational database and more specifically the relational model. If you already know something about databases, please pay careful attention because you might have to do some unlearning. Okay, I had this with I had a student who was a real good student in the last time I taught this. I don't know, maybe it's a year ago. Maybe it was a year ago when I taught this class, and he was an avid SQL programmer already. And he was just taking a bunch of courses that he had to take so he could qualify, or he was qualified to be able to have the right coursework to get into graduate school. And he was going to get into graduate school, but he was taking my course. And so it was tough because I asked him to write an expression or write something, and right away SQL was on his mind. And so he'd answer questions like that, and then he'd wonder why he wouldn't get credit because what he wrote produced what I was asking for, and so anyway, if there's any of you like that in here, we'll catch it early so you can unlearn what you need to unlearn to learn the concepts well. There's evidently a certain amount of overlap. You'll notice that with his language. But this seminar is aimed at audiences who do know something. Oh, this SQL and relational theory, that's the other textbook that's in the resources. If you go to textbook resources, there's the textbook for this class, but then there's another one in there that if you, I think I clicked on it in the video, but that's this book. And so actually, if you are someone that already knows SQL real well, that textbook does kind of parallel this textbook, but it's SQL from the very beginning, and it helps you learn stuff that way. So that might be something you'd be interested in looking at. This other textbook also goes into it more deeply, and I sometimes look at this textbook, which is up there for you, to get ideas on what I can do for quizzes and stuff for this class. So so there's this foundation section, and so we're going to spend time on that. That goes up to October, I think. That's when I do the first assignment. But then I do this Entourage after. I do this SQL part second, and I do this, because this Entourage is like transactions and stuff, and that comes at the end where we learn, actually going to learn how to write transactions and so on. And it's important that you know SQL already, because a transaction is a bunch of SQL statements, and we want to learn it by doing it. And so you'll have your server up and everything, and it's all web based, and so everything is you enter in your your store procedure, and you get it to work, and that's all you have to do, and then I go in and I can see the listing of your store procedure and that kind of thing. So what's a database? Well, so here he introduces our parts supplier database, which I just told you about earlier, and the database is like a filing cabinet, and the user would be like either an online user or an applications programmer, and you're going to be that. You're going to be an applications programmer kind of user, and you're able to the database. The database lets you insert new information and delete information and change information, or just retrieve information to look at it, and by issuing commands. And requests can be formulated in many ways depending on what type of user you are, and so on. So in this book, we're going to use text format. So, for example, this might be a command that you send to your database. And what does this command mean, or what do you expect from this command? Well, you would expect, this is pretty straightforward stuff, you'd expect a list of your employers or employees that are programmers, maybe. So, you know, job would be the name of an attribute. Programmer would be a valid value that could be that could occupy that field in a record. It's one record per employee. The name of the table or the name of the relation is called emp, and so that's the kind of stuff. Those are the kind of conclusions you can draw. You may be able to draw by just looking at a statement like that. Here's our table, and so a database system architecture, if you think of it how it would be broken down, we think of it this way: suppliers, parts, shipments. We think of the logical database, but of course, you know, that's supported by this database management system, but below that, its data is stored physically, and that can depend on a lot of stuff. But you know, whether it's stored on a disk or wherever, there are different database management systems have different, you know, ways or protocols of storing the information, and you can often move your data from one database management system to another by exporting the logical database from one to another, and so on. So each of these are independent. Logical database is perceived by the user. You have data independence. Physical database is the database perceived by the database management system. It's still an abstraction because really it's just a bunch of bits and bytes someplace on a storage medium, which you're going to learn about storage mediums too from those little study.com videos. So as I said, it's a database management system is an intermediary between the logical and the physical. It interprets and responds to and executes requests, protects users from data at the lower levels, and that's where all the constraints come in, and protects data from users. It provides security, concurrency, integrity, and recovery controls. Such controls are necessary because the database is typically shared. So you know, that's, you know, we go right into this from the very beginning, assuming it's a multi-user system, and we start from the very beginning. We write our programs just like two separate users who don't even know each other are attacking that same database table, trying to update that same employee at the same time. You know, I'm trying to update this employee's address, and the guy over in the next cubicle is trying to update the employee's phone number, and we're going to press the submit button at exactly the same time. And what happens? One or the other, you know, would get lost if we don't provide this concurrency control, for example. So security. security, users can only perform the operations that they're allowed to perform. When we set up our tables, there'll be a whole bunch of permissions that we can select. We usually just give the users everything, but you can do that. Concurrency allows the operations from one user not to interfere with another, and that's why it's important to. That's one reason why it's important for us to learn how to make transactions. It's to support this concurrency. You might be adding a new medical record information into the hospital database or something, and that one addition has to add stuff to a bunch of different tables, and you need to make sure that if there's two medical administrators trying to add something on a medical patient at the same time, that it's no data is lost, for example. But also concurrency. There's another concept that slipped my mind here. Integrity, it has to do with the database makes sure that you don't do anything you're not supposed to. Like you might write a perfectly formatted, syntactically correct command to put some salary value that's not a decimal number, or maybe even a negative salary value. It can keep that from happening. And then if the place blows up, the database should have everything in there somewhere, as long as your backups and everything are some off-site for you to recover. You might not be able to recover to the instant that the thing blew up, but maybe you can. You want to. So I do not use the term database to mean database management system. And so, what's a relational database management system? Well, it's a database management system that's got all the functions that you find in one, but also it's based on the relational model. So, relational model is a recipe for what the user interface is supposed to look like. Simple. The relational model, data looks relational. It looks like a table. Relational operators are available. This is a selection operator, or it restricts. It takes a relation, but you're in effect doing a subtraction, and you're subtracting something out of that. You're subtracting a relation from a relation, and this is effectively subtracting the original relation of S, and you're subtracting out all of the tuples in that relation where the city is not equal to London. Those are all being subtracted out. So it's another relation of all the tuples in S that are not London. You subtract that out, and you end up with a relation that only has tuples from London. So that's that example. So we're going to take a look at different kinds of relational operators. We've never implemented a real language based on the relational model, because there were databases around before 1970, 1971. It wasn't until 1970 or so that COD came up with the idea of treating data. He was a database guy at IBM, and back then databases were, you have the employee, and then the employee's got some nodes off of it. It's programmed. back before 70 on the 60s. So the Fortran programmer or the COBOL programmer implemented the database by programming, and records were stored as files on the disk, and it's not like the database programmer could write or could design a database and then somebody else could just come and write some code to access the data because it was integral. And so COD came along, and I think Date was maybe worked for him or must have worked for him because I think Date's younger. But you know, they were, you know, discrete mathematicians, I guess. I guess that's the area of math that this is, and they came up with this way of separating the data from the programming, but you had to have a large enough set of operations that you could just do on the data that could be where you'd be able to do everything that you needed to do. And so they started working on it. And there's some stuff that they didn't include, like apparently there's division. If you watch the videos, he sometimes talks a little bit about it. But anyway, so I took my first database class in like 1973, and it was this guy who came in from IBM, and we didn't have a textbook. We just had papers. He had these papers, and we read Codd's paper, and I thought it was great stuff. You know, it was one of those things where it's like I didn't have to study very long, and I understood it, you know, so that I always liked that kind of stuff. And so I've had an interest in this for a long time, but actually back then I was an electrical engineering major, so I was focused on other stuff. But I became interested again in databases back when the internet came along, probably before a lot of you were, I mean, when the internet was commercialized. In 1995, you know, and the Netscape browser came out. You know, before then I was an electrical engineering kind of guy, but then you know, I saw a graduate student here give a demonstration back in 1995, and it was a browser, and showing all this stuff and doing stuff with HTML and so on, and then came to a form. And the form was supposed to something that you could access the database with. Database? Well, you know, so how do you do that? What language do you use? Well, you can use Perl, or you can use Java, or one of those languages that were around back then. And then I knew that was kind of the place that was going to be my interest, and so that kind of revived my interest in databases, and so that's what I did for a while until I came back to teaching. But anyway, so if you continue on with this stuff here, here he talks about programming and the different kinds of statements. You know, we've got in programming languages we talk about types and the integers and so on, variables, assignment statements, literals, which is kind of a variable except for you can't change it. Or a constant. Values are what variables contain, but also it's the result of an expression, and so expressions are evaluated, and expressions are made up of these operators and so on. And so he talks about all these operators over the next few chapters in this kind of context. And then we return to it towards the end, like at the end of September, and we sort of, you know, summarize everything, and then we have got this nice model of how things work in our head, and then we actually dive into SQL more. So variables, expressions, operators, and then we have exercises, so now we're at the end of the chapter. Exercises. So what do you think of the following tutorial D? What do they represent? Well, this is just a parts table. but it's only the parts where the weight is less than 12.5, and so that's just this two record parts table. And then this is the parts table. If you think of this, okay, so this here is called. Can you see that? Oh shoot, you can't see that, so I'm pointing away on the screen. This. Never mind, this is no good. No, disk. Oh, okay. So let me get rid of this. Let me move this over here. And see that. So this is called a restriction, because you are restricting the tuples of this parts relation, which is all the parts, P1 through P6, but only the ones where we only want to see the ones where the weight is less than 12.5, and there's only 2 of them. This here is called a projection. Okay, we want to see all the tuples or records in the parts table, but we only want to see three of the columns. We only want to see the parts number, we want to see the color, and we want to see the city. And in this here, you can imagine we're actually doing an operation. This is like an assignment statement, because we're actually changing S. We're taking S, we're operating on it, and we're putting the value back into S. So it's like S, some operator equals something, and that would be deleting delete S where status equals 10. So we're subtracting out all of the records with a status of S. There's a status column in the supplier table. And here we are actually doing another assignment statement, but we're actually changing some of the tuples. We're changing some of the tuples where if the status is greater than something, we're adding 5 to the status. And this is a good exercise, because he was explaining all those components, and if this were really an important theoretical class and preparing you for graduate school, and you're going to go off and do database research, I might spend more time on this, but it's all pretty obvious anyway. You just got to think of it. But anyway, I think that's it. That's it for this chapter. So anyway. So it's 2:40. I guess we're done. So I will see you next day. Are there any questions? Okay. So yeah, you're welcome to attend online. And you notice I did not see 3 people had a question. Sorry. Yeah, we can work on this when we next time, I guess. All right. Anyway, thanks for watching.